All right, so tonight we are going to kind of continue from the basics of Python. We're going to look at dealing with files. We're going to look at different file formats or data formats. And then I'm going to show you Hackerrank, which I'm not. Has anybody used Hackerrank before? No, it's kind of a fun way to continue learning and test your development skills. Um, Going through all, I got to all the homeworks earlier today, and there were a few common mistakes that were made throughout, and I want to make sure we cover some of those basics before we move on too much. So I'll try to point things out as we go through code tonight. Um, and for you, I know it's kind of hard to watch slides of code without practicing. And so at the end, I want to give the opportunity for us to write some code live again and see if there's any questions or anything you guys want to dig into more, so we can have kind of an open agenda at the end of class. But for now, let's get started. So files on your computer. You're all familiar with files on your computer, I hope. They're a way to permanently store data on persistent media, like your hard drive, a network drive, or a USB stick. Files are in a folder or a path, depending on what language you want to use. And typically they have a file name and an extension, right? So those extensions help your operating system know what to do with those files. So things like PDFs or Excel or Word docs or anything else you might have on your computer. Your operating system will know based on that extension what to do with those files. And for our purposes, files can either be text files or binary files. Binary meaning encoded data that's not necessarily in like a UTF-8 or an ASCII encoding, or it's just binary data. And we are going to be looking at how we can deal with files in our Python applications. This is going to be critical when we start loading large data sets from files that we download online or that we generate. And so that's the way of handling and passing around large bits of data is through files. So in Python, there's a built-in kind of top-level function called open. And open allows you to open a file handle. So it allows you to open a file whether you're going to read it or write it, whether you're going to be allowed to create a new file or append to a file, or tell it's binary or not. And this open function has a couple of parameters to it. The first two are really the important ones that we'll focus on. The file name is the first parameter. And that would be a file full, like a relative or an absolute path on your file system. So like in your home directory, you could open a file called data.txt or something like that. The mode is the second parameter, which you tell the function what you want to be doing with that file after you open it. So if you're going to be reading it or writing to it, it uses different operating system permissions depending on what you are going to be doing with it. For instance, on a Mac or on a Unix-based system, files typically have pretty open read writes, so pretty read permissions. I'll use the permissions word instead of writes. Read permissions, meaning anyone can open pretty much any file to read what's in it on a Unix operating system, but writing to it is a different issue. Writing usually has a higher elevated permission needed. I always forget to stop the Zoom recording. But this is kind of the Python interface to operating system commands. So any programming language can open and close files and write to files and read from files. I don't know if you have done this before or not, but hopefully with the code that we'll be walking through shortly, you'll see that it's relatively straightforward. Any questions about files on your computer? Pretty easy. Cool. One thing of note before we start opening files with code, you always have to close your files when you open them, after you open them. Computers typically have a limit of how many files can be opened by different applications. And if your applications end up opening too many files or having pointers or references to a file, and there are too many of them open, bad things would happen. Your computer could crash. Your program will most certainly crash. So we always need to make sure that we are closing files. And so if we look at this first 3 lines of code, without going into the details of what everything is doing, the first line is opening the file to read. It's reading the file, and then it's closing the file. We haven't talked about exceptions or errors in our applications yet. We'll do that next week. But if you're writing code like this and there is some sort of exception or error that happens within your application, it could get to a state where it doesn't actually close the file. So the format we always use for opening files is a new keyword within Python. It's called with. What with is doing, it sets up kind of a block of code that will destroy every reference that is created on that line when the indented block of code underneath of it is complete. Whether it's complete by normal operations or complete by a error, when we get to this last line of code or anything after this contents read line, that file handle will automatically be closed. And so whenever we open a file, you'll see it in this kind of a format. So what it's doing with open this file as f. F is a variable, and that variable will be whatever file handle we opened. And so then we can use that f variable to do things like read from the file. All right. The first thing we will look at is writing data to our files. In this case, we are going to be writing text to that file, like I said earlier. And one of the reasons we will primarily be writing text files is you can open it with a text editor when you're done and understand what is in it. We can write standard text to it. We can write JSON. We can write CSVs. It doesn't matter. But if you open it in Notepad or some other text editing software, then you can see what's in the file. So looking at this example, we'll set up this cars list and add some dictionaries to that list. So the list after those lines of code will have 6 dictionaries in it. Each of those dictionaries has a key of ID, color, make, and model. So in our next block of code, we'll use that with keyword to open a file called data.txt. And we're telling the operating system that we want to write to that file. So we use that W. It's a string is the second parameter. We'll send the value W there to say we want to write it. And again, we use F as our variable. And then within that section of code, you'll see my next for loop is indented. I'll run a for loop iterating on the cars list. And for each car in that list, I'm going to write that car information to the file. And so you'll see I'm kind of making a comma separated file in here. Those are outside of my formatted strings. So in the end, we should see a file that looks something like this. Cat is a Unix command to print out a file. So we'll see my first line is 1 blue forward flex. To go back up, because I got the values from 1 blue forward flex. ID of 1, color of blue, make of forward, and model of flex. And I wrote to the data.txt file. So when I print out that text file after I execute that program, you'll see the data in there. It's almost like magic. Any questions on how that worked? No questions. Cool. Whoops. So I do like my formatted strings, so we'll use formatted strings all over the place. Then we can read that file. So I'm going to introduce a couple of new things in here real quickly in this 7 lines of code. Here I want to start with an empty list, again called cars. This would be another program, the second program that would read the data from that file. So again, following the same format with open data.txt, but instead of a W, I'm passing an R for read, because now I'm telling my operating system I'm going to read the data in that file, and assigning it to the variable f again. Now, one of the functions on a file handle or file object is readlines. So that readlines function basically breaks up the text file on new line characters. So the file before, you'll see one line of output. There would be a new line character there, another line of output, a new line character here, another line of output, etc. And so I will read iterating through each line of that file. There are other read functions on a file object. You can read a certain number of bytes. You can read the whole file at once. There's a whole bunch of stuff you can do. But for an example like this, read lines is probably most likely to be used. We talked about stripping strings, right, where we remove white space from the beginning and the end. When we read lines, the last character of that line string is the new line character. And so I like to strip it, take off that new line character. Then a string has another function called split. I don't think we've talked about split yet, have we? No. And so what split does is an optional parameter is a string, and you can say split this line of this string on this character. So here I'm comma separated. So if I call that split function, the return is a list. It's an array of the things between the character that we split on. So if we look at this line of the data and we split on the comma, I'll end up with a list with 4 things in it, 4 strings in it. The first string would be 1, the second would be 2, third forward, and fourth flex. So from that list, I know there's going to be a 0th or first element of an ID, and I'll assign it to a new dictionary. The parts is the list that was created after the split. The next element is color, the next element is make, the next is model. And so I'm making a new dictionary from all of those attributes. This is not the safest code to ever write. I'm not checking to make sure there are 4 elements in that parts list. I'm not handling it if there aren't any. But for this quick example, we can see that I can now pull in that data and put it into whatever structure I want to. In this case, I'm building a dictionary. And so I'll run that code, and you'll see the last thing I do is print out whatever is in that cars variable, which is a list of dictionaries. Everybody with me why it's a list of dictionaries? Any thumbs up, any nods, anything would be great. I got 1 nod. Thank you, Caitlin. I'll assume everybody gets it then. So when I run that code, I'll run readcars.py, and the output is that data we just read. It is a list of dictionaries. All right, JSON is a better way of printing out data like this because we can format it to make it, come on, stupid thing. We can format it to make it look better. JSON is, I think we talked about it before, is a JavaScript object notation. It is a text-based format for sharing data. It looks an awful lot like this Python string data as we're printing it out. It uses the same brackets for arrays and the curly brackets for objects or dictionaries or maps, whatever you want to call it. So when we run this, in Python, we have a JSON library that we can use. And this library lets us convert Python objects to and from text in the JSON format. Very simply, there's a dumps function on the JSON package that takes in an object, and it converts it to a string. Dump string. So the S record is a string. And so I will run this again, and you'll see the second line of code is now in JSON. Okay, well, it didn't really change all that much. Instead of single quotes around my strings, it has double quotes around my strings. Other than that, it's pretty character for character the same. So we can make it prettier. JSON has some optional parameters. A couple of them like sort keys and indentation. I can now print it out and I get a much easier to read list of cars. Now we have a human readable format that's in a standard structure. We can put it into a file. We could make an HTTP request like we did last week using this JSON. One thing I typically try to do when I'm learning a new programming language is how do I get data into JSON? So I can debug, so I can share the data. It's one of those core capabilities that for me always helps interchanging data between two applications, which is what I typically do when I write applications. And when we start doing data analysis more, we will be seeing data structures like this regularly. Good. There is an equivalent load string. So you can take a JSON string and load it backwards into a Python object. The load function or loads function usually returns, well, depending on your top level element, like in this case it would be a list of dictionaries. If the top level was a dictionary, it would return a dictionary composed of whatever was in that dictionary. So writing JSON with dumps and reading JSON with loads. CSV is another format that we will use heavily. A lot of the data analysis packages that we will start serving soon will deal with CSV files very nicely. And wouldn't you know, in Python we can read and write CSV files natively as well. So like a JSON package, there is a CSV package we can just import. And using the same kind of structure here, I have my cars array, my cars list, with open data.csv. So I'm changing the extension on my file. After I run this program and I write out to a CSV, you could open it in Excel and it would look good. I am writing, and I'm telling it my new line character is going to be empty because the CSV writer appends a new line at the end. And I'm going to call it a CSV file as my variable name. Now CSVs are, you could almost think of them like a database. And if you have your your headers in your file, it'll tell you what the names of the columns are. So that'll be when you import your data into Excel, it'll say, does the first line contain column names or something like that. And so here, we need to map that dictionary that we have to the output CSV by telling it what the fields are in our dictionary. So I'm going to be writing out the ID, color, make, and model fields like I did before. I'm going to create a variable called writer. That is a dict writer, dict meaning dictionary. The file that I will be writing to. And since I want field names output into my dictionary, or I need to map the my dictionary to the output CSV, I have to tell it the field names. And then an optional function to call is writer.writeHeader. This will output that header line. And then I can simply call writer.writeRows cars, cars being my list. Alternatively, if you wanted to, you could do a for loop and just write an individual row. Notice no S at the end of write row. But here I can write all the rows at once. And my data.csv file looks like I think we would expect it to. The first line is the header, specifying the names of the columns. Then the next 6 lines are the data from my dictionaries. Pretty fun, huh? I linked to the documentation for CSVs because there's a whole lot more stuff in here. There's a reader and a code sample, which is nice. There's a writer. A dictionary reader and a dictionary writer are specialized writers and readers, meaning they natively deal with the dictionary object. If you don't do a dictionary and you want to do something else, then you can. There's a whole lot of other I guess more low-level operations you can do. And there's a whole lot of information in here. So that's pretty cool if you want to ever look at it. Oops, where did I go? Nope. Let's go back to slides. Here. No, I didn't do a new link. All right. Any questions so far? All right. So here's a made up but semi-real world project. And we're going to be dealing with multiple files at one time. So I want to show you how to do that in Python. A couple of reasons you might do that is to read from one file, convert the data to another format, and write it to an output file. In this case, I want to read a text file and separate the data into small words and big words. So if you're not familiar with Project Gutenberg, it is a website with a whole bunch of text. Whoops, I just saw the chat. I'm going to go back to something real quick. Yes, to the question, can I explain what sort keys true is, again, in JSON? So you'll see the keys, color, ID, make, and model are alphabetized. If they are not sorted, then that output could be inconsistent from one dictionary to the next. But since I'm sorting it, I'm kind of forcing it into an alphabetized list to make it easier for the human eye to look at it quickly and understand what the different objects are. When another application reads it, it doesn't matter if it's sorted or not. Human eyes like to find patterns, or human brains like to find patterns, and so if we see color in the same place all the time, we can go color to color to color real quickly. All right, Project Gutenberg. They have a whole bunch of books that are free. Did it go? And readable. In this case, we're going to play with Homer's Iliad, which I assume everyone read in middle school. No, not Homer's. Well, we didn't read Homer's Iliad. We read somebody else's Iliad. Anyway, whatever. There's a whole bunch of books on here. They're all typically old books that have no license or no trademark restrictions on them anymore. And so it's a fun way for me to have data for us to play with. So if we look at like the top 100 ebooks from the last 7 days, Beowulf, Pride and Prejudice, Alice in Wonderland, Frankenstein. These are all books that are well out of copyright status. So you'll see I think they're all public domain. Public domain means you can do whatever you want with it. You could print this and sell it. You can make an ebook and try to sell it on Amazon. We all own the rights to it. No one owns the rights to this book. So anyway, on Project Gutenberg, they have the books in different formats, like HTML, EPUB, and plain text. I don't know the contents of this book, so I'm daring. But what I was looking at was Homer's Iliad, which I think was in the list. There we go. So here we have a plain text version of Homer's Iliad. If we wanted to read it, we could. It looks kind of oldie English, but that's okay. It's still a whole bunch of data. This is going to be kind of our first foray into dealing with large data sets. So what I want to do, I want to read this file. I want to pull out all the individual words in this book. And if they're big, I'm going to put them into a bigwords.txt file. If they're small, I'm going to put them into smallwords.txt. And I made the arbitrary decision that a big word is more than 5 characters long. So 6 or more characters is a big word. Project make sense? Cool. There are 1.5 million ways you can do this. But I did it this way. What we are doing here is we're using one with statement to open one file, iliad.txt. Open another file as big words, bigwords.txt. And can't see it all over there. There we go. We are also opening smallwords.txt as small words. So we'll have 3 variables for 3 different files. The first one we are reading, iliad.txt we're reading. The second one we're writing, and the third one we're writing. Oh, come on. Go back that way. Okay, cool. You'd think I'd get a hang of this someday, wouldn't you? All right, here we go. So, calling the read function on Iliad, Iliad being my iliad.txt file, I'm going to get all the contents of that. That is every word, every space, every new line, every comma, everything. Then I want to go through here and remove those punctuation marks, those new line characters, and everything else that's not really a word. So I'm going to create a string of a whole bunch of different characters. I'm going to loop through that string. So 4 character in strings. I don't think we talked about looping through a string yet, but you can loop through it just like you can a list or a dictionary. When you do a for loop on a string, each time you get a new loop, the character is 1 character in that string. Python does not differentiate between a string and a character like languages like Java or C do. So each loop will have a single character string in the variable. So it is a string object, but it's a single character. And I'm going to replace those characters with a space in the text. Just a super quick way, super inefficient way of replacing all that punctuation and new line characters with white space. Then I'm going to lowercase it all for fun. I'm going to use my split function, which returns a list of every word effectively. In this case, the default value or the default split delimiter is a space. So we're going to split, we're going to get a, this is a big book. So this word list is going to be gigantic, like really, really big, but that's okay. For fun, I print out the first 100 words just to see them on the screen. And then for each of those words in the word list, if the word is longer than 5, if the length of the word is greater than 5, I'm going to write it into big words. Big words.write, a formatted string with a new line at the end of it. And then small words.write, same thing. A small word. So if it's not big, it is small. Can everyone kind of visualize in your head what's happening? I got one yes. Yay, one yes. And a thumbs up. Thank you. Feedback is great. Okay, cool. So now we're going to take this one big file. We're going to split it into two smaller files. So when I do that, head is another Unix command. I'm going to see the first 10 lines of the big words.txt. And you can see here are my first 10 big words. Invoking, Minerva, repressing, Achilles, etc. And the first 10 small words, the Iliad of Homer, the Muse, Mars, the Fury. So somehow I imagine you take those 20 words and put them together, and that's the first couple of sentences of the book. Maybe. So let me run that for you just to show you what it actually looks like. Code. So process Iliad is my file that we just went over. Oh, where's my Iliad book? I've got to download it again. I'll show you what happens when we don't have that file. We should get an error. No such file. I must not have added it on one computer. But that is okay. We will download it. Here. Nope.
Files called big words and small words.
Sorry, can you speak up again?
Just so the Iliad text and then big words text and small words text, those have to already exist, correct? Or
No,
they don't?
They do not. They do not have to exist. Gutenberg, Iliad. I'm going to just download this file real quick. But, great question. But you'll see now, okay, those files do not exist now. Right, the only text file I have is iliad.txt. Big old file of the book. I don't know how fast you can see it, but it's screaming by on my computer. So, Python process iliad.py. And here is the first 100 words. They're different because before I had stripped out the junk in here. There's a whole bunch of like Gutenberg junk to get to the actual book. So I'll strip all that out. Invoking, Muse, Minerva, repressing. See, I told you, first couple of sentences. And then now I have a small words.txt and a big words.txt. So they did not exist before. So one thing that is interesting, you remember all those parameters to the open function, like the different form modes, I think they called it. Let's do something real quick. I'm going to make these empty. What? Yes, I can. Cat. Oh, I guess it did work. So you can see those are now empty files. I'm putting some garbage into both file. When I run the process Iliad file as is, it will overwrite those files. So if I open up big words again, you'll see my junk just disappeared. It's not at the top, it's not at the bottom. When I open these, I open big words in write mode. One of the parameters was one of the modes was X for exclusive mode or exclusive create mode. If the file exists already, now it will fail. Must have exactly one read, create, write, append mode. Okay. WX, so it's just an X. File exists. I got an error. Echo. Oh, echo. That's what I wanted to do. Duh. Hi, mom. Big words. Echo. Hi, dad. So I put hi, mom, hi, dad in those two files. Instead of X, I'm going to append. See, I'm changing the W to an A now. Now my hi mom is still there. I'm a mama's boy, what can I say? So that's the difference between write mode. It doesn't matter what's there. If the file's already there, it'll overwrite it. If the file's not there, it'll create it. The X is the exclusive create mode. If the file is there already, the program will fail, or there will be an error. The A is for append. If you use A and the file doesn't exist, it will create the file. If the file does exist, it just writes to the end of it. So right now you'll see those are pretty big. Let's see. Small words is 598 kilobytes. If I run it again, now it's 1.2 megabytes. Now it's 1.8. So I'm appending every time. So it's just rewriting this or adding to this file every time in append mode. Let's put that back to write mode. And now we're back to where we expect to be. I ran through the execution of that code quickly, but I feel like we beat up the actual code itself with enough explanation. But is there anything anyone would like to see or talk about again? It's pretty clear. I agree, but I know what I'm doing too, so. Let's see. How would I sort this alphabetically? The word. Someone, can you explain the word list ratio again, please? What do you mean ratio? Oh, the 0 100. Yeah. So word list is an array, or it's a list. Sorry, technically it's a list, and so I could print out the whole list. If I want to get access to any of the elements in that list, I access it like an array. What I do below is I want a slice of that array list. So instead of one element, I'm going to get all of the elements by index from 0 to 100. So if I do these to variables, and I print out their types, X should be a string, Y should be a list, and I believe it's exclusive, 100 exclusive, but we'll test with length. So if the length is 100, it's exclusive. If it's 101, it's inclusive. Oh goodness, I don't want to print out that whole list. It is exclusive. So one single element is in this case a string. The second one, the 0 colon 100, it's a list of 100 elements because it's exclusive. And there's a whole bunch of stuff you can do there. If you wanted to get everything, let's say after the 50th element, you can do, I'll show you in code instead of talk through it. After 50, I could do word list 50 colon close bracket. It'll give me everything after the 50th index and beyond. Fun things, I can get the last item in the list with a negative number. Second to last item in the list. There's a whole bunch of cool stuff you can do in there. I didn't link to the code in the slides, but I will, and I'll leave this stuff in there too. Good questions. Love questions. Love the interaction. All right, we did that. And so I got my big words. One thing that you will see a lot is how do we count the words? How do we count all the words in the file? And not just how many words are there total, how many unique words are there? And even more fun, how many occurrences of each unique word is there? So I imagine the word Iliad occurs a lot. The word the probably occurs the most. The word sassafras probably doesn't occur at all. So how do we figure out how to count the words? Let's do that. So here I have a program that we have seen parts of. We have seen this much for sure. Opening the file, reading the file. I'm printing out how many characters there are in the file. Then I'm lowering it, splitting it, replacing all the good stuff. Then I'm going to count the words. After I count the words, I'm going to perform frequency analysis, which is my simple way of saying count the individual words. And then we're going to print that all out in a fun way. So I broke this up into functions, which I know we've touched around functions a bunch of times, whether it was the open function or the functions on strings and whatnot. But here, the reason I'd like to have homeworks with functions, or in this case, a more complicated application than some of the simple code snippets we've written, is now you can consider it a modular application. So when you develop software in the real world, you have to test your software. You have to make sure it works. And if you have one big block of code that's 300 lines long, that's really hard to test because you're going to have dependencies in that code. You're going to have a whole bunch of branches of scenarios in your code and whatnot. So the more you can break it up into kind of isolated functions, you can test functions individually. So here, if I wanted to test this function, the read file function, I pass in a file name, I open the file, read the contents, and return it. That's really easy to test because I can pass in a known file name with known content, and I can just compare that string that gets returned to my known content. I don't care that it's in the context of counting the words in an Iliad, in Homer's Iliad. All I know is that that function reads a file and returns its contents. Same with the function above it. This one is more complicated. We're going to walk through it. You don't have to understand it yet. But I know I'm going to pass in a list of words, and its output is going to be something very predictable. So in my test case, I would call this function with a small list that I can write by hand and count by hand. And when I look at the output, it should match. That's testing the function, and it's called a unit test, and you're going to test this one unit of code. And the reason you do that over time in an automated fashion is so you don't break your code inadvertently later on. So when we start building unit test cases for code like this, when we build applications, those unit tests would run automatically. And if they fail, that means you broke something. And that's good to find before you roll it out into a production environment. That's the bad place to find bugs. You want to find bugs in your unit tests if you can. So anyway, so for this, in my main function, I'm creating a file name variable, iliad.txt. I'm going to read that file, and I'm going to get contents. For fun, I'm printing out how long the text is, how many characters are in that text. Doing the replacement of those those non-word characters with white space. I'm going to lower it all, and then I'm going to split it. So this word list is a list of strings, a list of all the words in the book. I'm going to call the count words function, print out the word count. If you look here, my first iteration of this, I wrote a little word counting algorithm, keeping track of white space or not white space, and it was kind of fun. But then I said, oh, wait a minute, I can just count the words because it's already a list. And so I'm just going to return the length of that word list. And then I'm going to call the fun one, the frequency analysis function. I'm going to blow you away real quick. Everybody ready? Okay, cool. So, my frequency analysis function. Anybody know what this is that I'm highlighting? One no. Nope. Nope. What does it look like? If you look at the line above it, what do you think the def keyword means?
Does that create a function?
Uh-huh. Yep. Def is defining a function. What's it called, Caitlin?
Called mapper
With a parameter called?
word.
Awesome. So I'm making a private function. This function is only callable inside this frequency analysis function. I didn't have to do that, but I did because it's kind of cool. All that function does is returns the number 1. Hold that in your head because we're going to get to that in a second. Literally the next line of code. There is a magic Python function called map. Has anyone heard the term MapReduce or map filter reduce? Hadoop MapReduce? No. Every time you see, so MapReduce is it's a way to take a large data set, and it's really meant for breaking it up and distributing workloads and then bring it back and recalculating everything. The idea here is this map function, the first parameter is a function. So the first parameter to this function is a function. The second parameter is a list. What map will do, it will call this function for every element in that list. So every word in that book will call the map function. The output of that is a list of the mapped value. What is the mapped value for every word in that list? One. Yes, 1. Because I'm returning 1. So imagine my word list was 3 words, 2 words. Hi, Mom. Okay? Let me rephrase that. My list was 2 strings. The first string was hi. The second string was mom. When I call this map function, hi gets past a mapper and mom gets past a mapper. Both return the value 1. This mapped variable is a list of those returned values. So how many elements would be in this list? 2. 1 representing hi and 1 representing mom. Perfect. So now in Project Gutenberg's Homer's Iliad, I don't remember how many words are in this book. Let's say there's 263,000 words in this book. How big is my mapped list? 263,000 elements, all of which whose value is 1. The important part here is that the length of this list mapped is exactly the same as this word list length. So now I have 2 lists. Word list, hi mom, mapper, or sorry, word list hi mom, mapped 1 1. Can you visualize that? 1 yes. Yes. I'm contemplating breaking this out into code to run it. So I'll do that because I got a somewhat. And I love somewhat because that means you're thinking and paying attention. Test.py. All right, I'm going to do this whole thing, but I'm going to short circuit it all. I want word list equals hi mom. And I will comment all those out. We don't need the length. Okay, cool. So all the comments down here that I just commented out the lines of code, it's reading the Iliad file. I want to deal with a custom word list called hi mom. Let me show you the output that we're building towards. That might help. Oh, well, that was word count too, because I commented all this stuff. All right, this is what I am looking for. Almost. Hi, 1, mom, 1. My mom goes by Mom with her grandkids. So now you can see mom, 2. Let me print out my word list. Whoops. Okay, so here's my list of words. There are 3 words. Mom is in here twice, and hi is in there once. Following?
Yeah, I get it now.
Okay, cool. Let me start printing things out in here. I should be doing loggers because that's the right way to do debug statements, but I'm in a hurry. No, I'm not in a hurry, but I'm in a hurry. So, input word list. Word list. Now mapped. Okay. Oops, that is a map. Map object. Iterative map object. Can I turn that into a list? I think I can turn that into a list. Yeah, cool. So this is now, my input word list is hi mom. In that map of the counts, right? All the ones. I have 3 ones. On its own, that does not make any sense, right? Because you don't know what those ones represent. But if we tie it to the input word list, now it starts to make sense. And that's what the next line of code does, is zip. We have 2 lists. We need to merge together somehow. Not in a list. Well, yes, in a list, but anyway. New mapped. My computer is not happy today. So the zip function, that didn't print like I wanted it to. What it's doing is taking those, it's combining the 2 zeroth elements into a data structure so they're paired together. Unfortunately, that was not printing out nicely. But I can iterate it. So 4x in mapped. I want a dictionary as my output. 4x in mapped. Oh, I know totally a better way to do this. Instead of jumping back and forth, there we go. Okay, now I want X in mapped. Well, that's odd.
Did you write it and save it?
I feel like I did. Test.py written. Okay, so that part worked. Oh, shoot. Okay, totally broke something in here. Oh, I know what it is. I think that listing the mapped in the first place was a destructive thing. Yep, that's what it was. Okay, cool. So, input word list, hi mom. Then I'm mapping every. These are not arrays. These are called a tuple. It's a multi-value structure, very much like a list, but lists you can change. So lists you can add things to it, and it's the same list. A tuple, if you try to add something to it, it's a different object. So it's called immutable, meaning it can't change. Not terribly relevant, but it's another container kind of structure. But here you can see like this tuple has two elements. Element 0 is high, and the second one is 1. So now I've started to add these together. And now I know why my code was doing something funny that y'all didn't notice, but I'll fix it. There we go. If x is 0. Okay, there we go. There we go. Okay, cool. So this hi mom, and then remember the 111. I can't show you the 111 because it broke something. But now the zip together is the hi 1 mom 1 mom 1. So now they're zipped into one list of tuples. And then I'm doing the reduce phase in a MapReduce here is I'm iterating through them, and I'm making an output dictionary, and in that dictionary, so x0 is the 0th part of that tuple, the string. If that string is not in my output dictionary, I will add it to my output dictionary with the value of 0. This is where I start to count and accumulate those counts. And then I add 1 to it. So if it wasn't there, I said it's 0, then add 1. If it was there, I add 1. So if it's there twice, my output is mom 2. So map, every word in the list gets passed to this mapper function. The return is a list, essentially. Zip, I'm combining those two lists. And then with this data here, this program part here, I'm just accumulating the individual ones into a bigger number. So my final grand totals were mom 2, high 1. Mom 3, Python 2, hi this is for and her. Total 11 words. With me so far?
Yep.
So now who's really desperate to see how many words and what are the most popular words in Homer's Iliad? Oh, I forgot to tell one more thing. We did list iteration, list comprehension, right? List comprehension for X in list, do something, return it back to the list. This is kind of the same thing, But instead of returning it into a list, what do you think we're returning? If it were a list, the outer brackets would be square brackets. A dictionary. Good job. So it's the same concept as list comprehension. It's still list comprehension, but instead of a list, I'm returning I need to make a dictionary, and we all know a dictionary is a key value pair set. So if we start kind of in the middle for KV, for key value in the important part, reduced items. Reduced is the thing I returned from that function. So the accumulated numbers. I'm actually sorting it on the count because it's a tuple, and it has the name, the key, the string, and the second one was the value. So I'm going to sort it on the value in reverse order, and then assigning it key value in my dictionary. I found this code online, and I was like, this is awesome. I'm going to show this off because it's really cool, I think. Anyway, and then then that sorted is being printed out key value. So you'll see here it is sorted by highest value first. All right, now we'll get to Homer. So word list. I want the real ones. So I want Iliad text. I'm going to read it. In read file, the function, that's where I open it, read it, and return the value. Replace all those characters, content, lower, split, word count, then do the frequency analysis. Oh crap, I'm printing out the big list again. I don't want to do that. Where did I print the big list? Did I do it up here? Yep, there I did it. Okay. There are a lot of words in there. Let's go that slowly. There are 1.1 million words in Homer's Iliad. Sorry, Homer's Iliad is 1.1 million characters long. 1.1 million characters long. There are 195,000 words in there. The was my most popular word. It occurred 15,000 times in that text. And of, to, his, in, with, a, he, from, on, there. No kidding, those are the most popular words. As, but, thy, all. Oops, I could have replaced a double quote. I'm looking for words that aren't just regular at, not, thus, there, shall, whiz, which, great, are. That's an interesting word. Through, more, Hector. I guess it's a name of somebody in the Iliad. These, or, one, now Achilles. So these are all the words in the book. Distant occurred 63 times. Inglorious was 31 times in the book. So this data set was huge, but it processed pretty quickly. Fun Unixy stuff, I can time it. Half a second. And that's when I printed it out. If I don't actually print it out, 0.34 seconds to process 111,000 characters, or 1.1 million characters, 19,500 words, or 195,000 words. That's pretty darn quick. So is this feeling like an advanced programming class yet? Good. I'm glad. It hasn't been before. All right. So that's that. The next homework assignment is a much simpler version of that. But it's still a lot of the same concepts as we did in there. You just don't have to map reduce stuff. Kinda. The idea is to add all of the numbers in a text file. The links got cut off, but I have links to A, B, C, D, and E .text. I've created you a function called add them all, and it takes a string as the parameter for file name. I have a return variable called sum, and that's what you will be returning. The way I'm going to execute this is like this below. Python solution, oops, it shouldn't be solution, it should be adding numbers. I'll fix that. Python adding numbers.py space a.text. I will get that file name from the system arguments, from the command line arguments. You will open the file, you will read through the file, you'll make sure everything's an integer, and you will add them all together and return the sum of that file. I have 6 different files. I need to give you what they all add up to so you can verify. But this is how I'm going to validate your homework as well. I'm going to run it against 6 other files and make sure your sums work. Put it in GitHub, week 5, adding numbers.py by next Wednesday at midnight. And then tell me on Canvas, send me a link to it. When you send me the link, if it has blob, master, that kind of stuff in it, that's totally fine. Your code should go in here. You shall not touch anything outside of those. You shall not rename my functions. You shall not rename my variables. You shall not touch the main function. Your code should go between those 2 highlighted lines. Clear? Example, a.text. Big list of numbers. If you're curious, there's an r.py file in my GitHub for how I generated that. I printed out a random list of integers, a random size list of random integers. There we go. I ran it 6 times, made a.text, b.text, d.text, e.text, etc. John, what the function should do. Your function needs to open that file, read that file, and add up all the numbers on the inside and return the sum of all the numbers in that file. A, B, C, D, and E are just different text files. So they're in my GitHub and linked from that other page, but they got cut off. But they're just random numbers in all of them. Any questions on the homework? It should be fun. All right, let me. Okay, there's that. How you? Yeah, from the slides. This a.text here is a link to it. And you can just download that file. The big secret though is it's in my GitHub. So, oops. Oops. Info 450. They're all there. But I'll clean up that slide so you can actually link them all. And this is not really the solution. It's just that empty framework. All right. What I want to do for a little bit as a way for y'all to have practice. If you're not practicing, you're not doing it right. If you're not familiar with Hackerank, it is a website it's probably a couple years old now. It's used for just this. The premise is that it is created for helping you with interviews. If you do technical interviews and you want to, get refreshed on some Python you learned 2 semesters ago or whatever, or Java or whatever language you are, you can go on here and you can do these little challenges they have. And so on the flip side, they have a Hackerank for employers. So a company like the one I work for uses either Hackerank or one like it, where the interviewer sits on one side and watches the interviewee, the candidate, code. And so the way they do it is it's the same as these practices. So we give a challenge with some framework code, fill in the blanks, hit go, and it runs it through a bunch of test cases. I am trying to figure out how to do homework submissions through this, so I don't have to validate it, but Hackerrank will, but I haven't gotten there yet. Anyway, so there's a whole bunch of stuff in here. When you log in, you have to create an account, so I just use my LinkedIn account to log in using OAuth like we talked about last week. But under skills available for practice, there's Python. So I clicked on it, and we can come in here and we can let's find some harder stuff. Okay, it's still easy. Success rate 98%. So let's click on text wrap. At first, their descriptions are kind of hard to understand. Yes, this is freaking amazing. I love this, and I really wish I had had this in college. When I was in Computer Science 201, my C programming class, my sophomore year of college, our professor had an automatic submission thing, but we had to log into a remote Unix terminal, type in his input thing, and hit the program name, and it would run through test cases. It was the most nail-biting, nervous thing. It's like, is it going to pass? Is it going to pass? Character by character comparisons. It was fun, and that's what this does. So here, you are given a string S and width W. So width is the size of your or the size of your paragraph. Here we're wrapping text. Your task is to wrap the string into a paragraph of width W. So input format, the first line contains a string, the second line contains a width. Cool. Constraints, these are good to know, but not terribly important. But we know the length of the string will always be less than 1,000 characters, and width will always be less than the length of the string. Cool. Print the wrap text as the output. Print the text wrapped paragraph. So a sample. A, B, C, D, F, G, etc., the alphabet, 4. So I need to take that string, split it, or wrap it at a width of 4. So you can see that's the sample output. Okay. So let's do it. So here, I can pick what language I'm going to do it in. Always pick Python 3. I don't know what version of Python 3 is. So like, if a formatted string doesn't work, then it's Python 3.6. Oh well, you might have to skip that. And so we can see like this red, orange, red, whatever color that is, we're not supposed to touch. So the wrap function is where we're supposed to put our code. All right, so that's where we're going to write our code. The part I love about this, I will hit run. And it's going to tell me, okay, your sample test case failed. My input was ABCDFG. For my output to the standard output, that's important, was nothing. And they expect this. And so let's have it. Let's do it. So, where do we start? All right, I'll give you this one for free. I know we're going to have to count. We're going to have to count a width. So let's make a variable called 0, or x. We're going to want to go through our string. We're going to iterate our string for a letter in string. Then we are going to want to print it out, letter. If then we're going to increment our x. If x equals max width, print a new line character. And then x should be 0 again. How does that feel? It won't work. But how does it feel? Run code. Input. Oh, that is weird. My output A, B, C, D, but all new lines. Okay, that's odd. And then none at the end. That's even weirder. Expected output A, B, C, D, etc.
Is it because we have to zip it?
No.
Nope.
What's wrong with this? That first line of output. What's wrong with it?
It's going to a new line after every letter instead of every fourth letter, right?
Perfect. So do you know why? Every time you call the print function, it adds a new line at the end of it. So there are a couple ways we could do this. Let's try a temp string. Temp string equals that. Yeah, that'll be good. Then we can, instead of printing the letter, we can, oh no, let's make it even more funner. We'll do a list. Temp string append letter. Now I have 1. If x equals max width, instead of printing new line, I'm going to print join temp string. I'll tell you what this does in a second. Temp string equals that. Join. It, since I'm taking the whatever character sequence I have here, and I am printing out every item in this list, followed by the thing in my before my join, the string I'm joining on. And so if it were like a comma, I would make a nice comma separated list. and it excludes it from the end. It's kind of cool. For here, though, I'm just joining it all together with an empty string. Then when I get to 0, I will print out my temp, or I'll print it, reset my temp string, reset my X, and go. See what happens. This won't work either. Whoops. String object has no append. Oopsie, because it should be an array. No, close. A, B, C, D, E, F, G, H, I, J, K, L. What's wrong? Can you tell what's wrong?
Is it because there's not enough letters left, or it only do it if it gets to the max width?
Perfect. Yep, there's no Y and Z. Because I never got to that max width again, so I'll just print out what's remaining in my temp string. That should do it. This one should work. Hey, look at that. So I got past this test case. That's awesome. Now when I hit submit code, they run it against a bunch of test cases.
Professor,
Yes, sir.
can you explain what Abby said again for why it, like what we did to make it work?
Yeah, that last thing I did.
Yeah.
Yep. So there are 26 letters in the alphabet, right? Yep. That is not evenly divisible by 4. The only time I printed out anything, so imagine I have an empty list. I get to the first letter A and I add it. My length is not 4, so I don't print it. Add B, not 4. Add C, add D. Now I'm at 4, right? I printed it. Reset it. E, F, G, H, print it. I, J, K, whatever, etc. Print it until I get to X. X is the end of a four character string. I print out whatever's up to X. But then I reset, add Y, add Z. I'm only at 2 length, but I don't run I'm not in my for loop anymore. I'm done my for loop because I don't have anything after Z. Right?
Right.
So all I did was, at the end, I just printed what was left. What was left in temp string.
Okay.
And that would be the Y and the Z. Now,
Gotcha.
they don't tell you what the other test cases are unless you pay for it. Or you can do it you can unlock it 5 times. Then you got to pay for it. But when it fails, I think they tell you when it fails, something like that. Anyway,
well, one more question. Sorry, I didn't interrupt you, but
no. This is the interactive session.
I feel stupid for maybe missing this, but I'll ask anyways. Where in the code do we have it set to be a length of, to set the length? Yeah.
Before?
Where do we?
So that's going back to the definition of the program. You are given a string S and a width W. So we as the developers have a width. The way they give us the width is in this function. They've defined this wrap function. So here's my string.
Oh.
And my width.
Gotcha. Okay. Okay, thanks.
Yep. All right. Let's go to the next one. Holy crap, this looks hard. Okay, this is easy. Let's do it. Let's do it. All right. Designer doormat. Mr. Vincent works in a doormat manufacturing company. One day, he designed a new doormat with the following specifications. Mat must be n times n. I don't know what that means. Neither do you. We'll figure it out, though. N is an odd natural number. Okay, so it's an odd integer. M is 3 times N. Okay. The design should have welcome written in the center. The design pattern should only use that one, a pipe, a period, and a minus sign. The input format, a single line containing the space-separated values of N and M. Constraints, output the design pattern. So, let me see if I'm understanding this right. So, N, odd natural number. That to me looks like the height. Everybody agree? 1, 2, 3, 4, 5, 6, 7 lines is the height. And therefore, N, the width, M, the width, is 3 times that. I'm going to forget that. So I am going to, oh gosh, I have to do the whole thing. Print output to standard out. So we haven't talked about this much, but user input equals, there's a magic input command. And for fun, let's print out user input just to see what it looks like. So when you do this Hackerank stuff, it's totally acceptable to hit run 8 million times. So you can see my input is 7 and 21. And so now I have 7 and 21 in that user input. So instead of using N and M, I'm going to use height, width. The first one is N. N is the height. So I'm going to give myself a comment. First number is height. Okay. How do I get that first number out of that string? Remember, the string is height space width, but in one string. Split. Good job. Equals user input dot split. Then to confirm, I'm going to print out my parts. I always call it parts. I don't know why. And correct. I have 7 and 21 in a list. So for my first one, height equals, I need an integer for my parts. Width from my parts. Actually, I want to see if I have formatted strings or not. Cross your fingers. I want formatted strings. Nice. Okay, cool. I have formatted strings. So now I have height and I have width. Now what the heck do I do? I guess I could print out a grid. In width, height, print. I'm going to give you a secret. Python 3 print. There's a way to suppress those new lines. And then after each, whoopsie, print, then I want the new line. So now I'm going to print out a grid. Whoops. Or X in, not width, it's range width. A range will give us 0 to that number exclusive. Okay, so now, whoops, I did that backwards. How did I do that backwards? Range width. Yeah, I did that backwards. So for everything in the height, and then in the width. There we go. Okay, I'm starting to get my mat. Does that look like my mat? Getting there. What should we tackle first? The welcome or the pattern? Let's tackle the welcome first. When do I print welcome? Middle row. Okay. Middle row. So X is height, X is odd. So how do I get the middle?
Would it be along the lines of like height divided by 2, but not?
Yeah, equals height divided by 2. So that's when I know I'm in the middle. So just for giggles, if is middle, I'm just going to change the character I'm printing out. Else. So this is not what they want us to do, but this will tell me if I'm in the middle or not. Whoops. Oh, if x equals is middle equals true. Something like that. What did I do wrong? X height divided by 2. Let's make sure we're comparing integers. Okay. I got middle. That's cool. Now how the hell do we put the word welcome in there? Okay, I know them. Do we just turn our output into something editable? That's a good idea. Ooh, that's a really good idea. I like that. How do we do that? I know how to do that. I know how we can do that. That's a really, sorry, I like that idea. I would never have thought of that. Output equals, it's going to be an array, a list, gosh. Then I need a list of, this is going to be a list of lists. So this will be our height. I like this code below. I'm going to keep it. I think logically this is going to work. No, it's not. X equals. Then that's what I want to do. Okay. So now we have a multi-dimensional array. For row in output, print, dot join output row. What did I do wrong? Oh, it's not output row, it's just row. Okay, so now I'm back to here. But now we can start changing things. So at this line of code, we now have a two-dimensional array representing our mat. So let's see, middle row equals int height divided by 2. So x in range width output now our middle row should be y or w's. Good. Is everyone visualizing a multi-dimensional array is kind of the hardest thing for me? We've created an array of arrays. So the outer array output, the 0th element of that is an array of width elements. I always like to print these out because now I can visualize it. So this is my 0th row and the 0th element. And this is my width minus 1 element of the 0th row. This is my width minus 1 element of my 5th row. Thumbs up, thumbs down? One thumbs up. Okay, so we can do this a whole bunch of different ways. We need to put the string welcome in there. Right, I think does it want all capitals? Yeah, it wants all capitals. How do we figure out which column the W goes in? We know we want the word centered. So if I start it centered, that would be int width divided by 2. 27 numbers of characters. You're something like that. Yes. Divide by 2, divide by 2. Yeah, it's going to be a whole bunch of dividing by 2. So my x column is going to be width divided by 2 minus the length of welcome string divided by 2, I think. Yeah. Do a quick another variable for character in welcome string. We will take output middle row number sub element x column plus y equals c. I think that's going to work. So the first time we get to this, welcome is welcome string. We're at the 0th element. C will be W. The C variable will be the capital letter W. Y will be 0. So we know we have our middle row number right. X column is where we want to start, plus Y. And then assign it whatever letter we're on, that increment Y. I think that's it. All right. Let's take that out because we know, I think we nailed this part. Everybody get how we placed that there? We found the middle of the row, and then we took the number of letters in that word, divided that by 2, and moved to the left that much. Yeah. All right. That was a fun part. So we're getting closer. Now how the heck do we do this one? Is it the same thing? So if we look at it, I see a repeating pattern, right? Dot, pipe, dot. Dot, pipe, dot, dot, pipe, dot, pipe, dot. Okay. So we've done welcome. And it looks like we have to do that on every line, except for the middle line. Right? Except for the middle, yeah, the middle row. So for x in range height, if x equals middle row number, then continue. Continue means stop executing this part of the for loop and do the next part of your loop. I want to follow the same logic to center this stuff. So here, cool Python thing, you can do string multiplication. But that's okay. We'll deal with that. Pattern string equals that. But I want to do this same thing. I want to put it in the same spot. So it's the same logic. I shouldn't be duplicating code. I should be making a function. But that's okay for now. Pattern string. So now every row is going to get that pattern dead center. I think that's good to start. Oh, only the middle row, my bad. Output, not middle row, but X. Well, that's not centered. Oh, because I'm doing length of that when I want to be doing length of pattern string. All right. Are we getting there? What else do we see?
You add to the pattern every time you go down again.
Uh-huh. Yep, yep, yep. So I'm going to take my pattern string definition out of my for loop, because in my for loop, at the end, oops, pattern string, I'm going to add to my pattern string. So I want to add another dot, dot, dot.
Will it add another 2 dot dot dots? Because wouldn't you just put out 2 then?
Times 2. You can multiply strings. It's kind of awesome. So I'll start with 1. Then I'll add 2. We got to start subtracting them at some point in time, but we'll figure that out in a second. Oops. Because I think I got too big. And let's do, well, we know we have to do something from the middle. So if we're at the middle, let's just reset that back to empty. Basically, the pattern string got too big, and so it ran out of bounds. So here I got it. We got it right. Then we added 2 more, got that right. Added 2 more, got that right. And then we reset it. So now it's this half we have to figure out. And so it's 1 times I'm trying to think of how to calculate how many of those we need. Because I don't think, oh, wait a minute. Here we go. So let's say if x is less than middle row number, then add. Else, how do we subtract them? Pattern string equals pattern string 0 to the end minus 6. So we talked about making this kind of substringy or sublist thing. So if I take the whole list and subtract 6 characters from the end, that might work. It started to do it. But it added 1 too many. Oh, I know. I think I have an idea. If x is the middle row number, row number plus 1, do nothing. Because I think I want to have the same after the welcome number. Dang it. Oh. Can I maximize it? I don't know. I'll start with string and divide by 2 each time. I think the problem is that the first time I have 1, the second time the first time I have 1 and then I add 2. The second time I have 3 and then I add 2. So that's when I get here, and I still add when I shouldn't add another one. So less than or equal to middle row. What if when I'm on the middle row, I know I'm adding right before, so let's just subtract. That looks pretty darn good. It doesn't like my pre-debuggy stuff, but I can take that out real quick. Green. That was pretty fun. If you like this kind of thing. So this test case is taking a long time, which means it's a big old test. They made us make a very big, I want to see it just to see it. Yeah, 81,243. I think I can test custom input. So I'll just run this, 81,243. It's even, word wraps in here. So we made a big old mat. That was fun. I like that one. Super cool. So they have hundreds and hundreds of these things, starting super simple. And so I highly recommend coming in here and just practicing with these. Reading the problem statement is one of the harder parts, in my opinion, just trying to get it to understand what they're asking you to do. But that's why I just start dumping out, printing my parameters and seeing what the heck it is, running it to see what their expected output is. And the fun part to me is then figuring out, like that last one. I really like that last challenge because it mixes kind of visual stuff with logic problems, and it could have been frustrating, but I think as a group we got through it. Good job, team. So on that note, I'm going to stop my recording. Don't forget the homework.